Alright, we're looking at test 2, spring 2016, looking at shear stress. And so we have a formula for shear stress, and it has two formulas, the basic formula and then the simplified formula, plugging in Q for here. We have I, and so we're basically looking at width, height from the geometry right there. And so we're given some data, and so we can type that in. And I'm just going to copy it just to simplify matters. And then we have a formula for tau xy, and it's based on W and H and V. And so we can put in W, H, and V, and then we also need to calculate I. So then we can label these cells. It's under formulas, create from selection. And so then we can enter our values. So W is 0.2, H is 1, V is 1,000. These are in inches. And then since we labeled the cells, we can say this is equal to W times H cubed over 12, and that gives us I. And then the other thing in our function is our Y, and so we can label this entire column Y. So now for our tau xy, it's equal to V times Y times Y minus H. And then to divide by 2I, you need it in parentheses, so it's 2 times I. So it has to be in parentheses. If you just did divided by 2 times I, you'd end up multiplying everything by I, order of operations working from left to right. So we can drag this down, and those are our values. So we've entered the data into Excel. We've calculated tau xy for each y. Now we need to plot the theoretical and FEA. So we can call this FEA tau, and this is theoretical tau. And so now we want to plot that. So as long as we have a blank space around the edges, all we have to do is insert, and we want to do a scatter, probably interpolated lines, and then we need to change the markers. And so if we come here, so this is a theoretical. The theoretical we want to be a solid line with no markers, and then we can change our switch to our second series, and this will be markers and no line. So we're plotting them separately, and we can make our markers a different color. Let's say red. Oh, that's a line. Fill, also red. So now we have red markers and a solid line for that. And then we want to label our axis. And so we can come over here and add plus. We want axis titles. And this is your shear stress tau in PSI. And this is Y in inches. So then we want to end a polynomial trend line with 0 intercept. And we want to choose something reasonably fitting the data. And we want to plot the R squared and the equation. So we want to select our data, right click, add trend line. Linear doesn't fit. If you go to polynomial, if we show our equation in r squared on the chart, r squared is equal to 1 is a perfect fit, and then we wanted to set the intercept at 0. So that's the equation, and if we look at this equation here, it's also a squared formula in y. So that's our equation, and we want to insert and then we want to axis limits to limit legend and things like that. So this goes up to 1, and then we want to make this only going up to 1, and then for our legend we can have it to the right and then overlap the chart. So we can have that there and this down here. And I don't think we were asked to title this, so we can just delete our title. So that's problem 1. Problem 2, we need to plot this function between 0 and 10. So we need a new sheet. And then we want x to go, our x, we want to go from 0 to 10, so we can start at 0, and then we can, where's fill series? Insert, no, where's our fill series? Oh, now we can fill a series, and the series is in a column. We're going to go linear, and the step value we want is 0.2. We want to end at 10. We could have also did 0.2 and then dragged it down. So there is our x, and it does stop down here at 10. We label this column x, and then this would be f of x. And since we label this column x, we can just type in our formula. So it's equals to 8 times sine of x plus cosine of x minus 2 times x squared plus 15 times x. Control Enter to keep us in the same cell. And there's our plot. And then we can now insert a line, and then the title, the x value of the maximum y. So the maximum y is around 2 point something, so it's 2.2. So peak is at x equals 2.2. So that's problem 2. Now we have a control chart. So we need a new sheet. And then I'm just going to copy this over just to save some time in the video. And so, and then, oh, this is weird. That's strange. Yeah, hopefully it'll still work. And so, basically we need to do the average. So that's equals average. No, that's not average. The average. So machine operating property. So average diameter on the first axis. So we need to calculate the average. So the average of those. And drag that down. And then the range is a second, and that's the max minus the min. So this is equal to the max of these minus the min of these. Control Enter to keep us in the same thing. And then the x error in millimeters is equal to, the max error is the max minus the average, so it's the max of this minus the average, which is there. Drag that down, and this is equal to the min of this, oh, it's the average minus the min. So it's the average minus the min. So it's the average. Error is average minus min. So now we need to plot this, and what we're wanting to plot is R and our average. And then we use error bars to indicate the range. And so what we're wanting to plot is this and average and R. And since this messed up the formatting, I don't think it's going to label things properly. And we want to insert this. These lines we want to be straight lines with dots. And then we can, if we go into select data, we can edit our series. This is the average. And this is the R. So now we have average and R. And in this we can change our marker to be a star so it matches that. And then you couldn't see the colors, so that doesn't matter. So now we have that. Now what we need is lines going across here at the 30 and then the 31 and 29. So that's 30 plus or minus 1. And then another line here at 3. So then we can come up here, and we want those to go from 0 to 6. So we have the x value goes from, or the time goes from 0 to 6, and then d bar minus std is 29. And then we have the d bar is 30, and the d bar plus std should be 31. And then we can copy those down, and then we have our max is 3 and 3. And then we can select this data, copy it, go to your chart, paste special. We want these to be new series. The y values are in columns. Series names are in the first row. Categories are in the first column. Now we want to change our lines here to be dashed, actually dotted, and we can make these both the same color. Let's say red, and this can also go to red, and then your green, you can go back to blue, and then this was a dashed line. And then we can go to our markers and do markers none. For each of these. And then we need to go up to 6. And so, axis options. Then we want to go up to 6, which is 0.25 hours. And then 1 hour is 1/24th, so that's 0.04 for our step size. So this is 0.04166667. And then we want to start here at 0, and just leave that at 6. So now we're at 0 to 6 hours. Now we need to send our R's to the secondary axis. And then we need to set our range. So this one we want to go from 23 to 33. And this side we want to go from 0 to 10 in step of 1, and then this one we want 23 to 33, and then this one we can also make step of 1. And then we need to add our labels. We want to move this to the right. And we don't have a title. And then we want to add our axis titles. And this is time in hours, diameter in millimeters. Oops, one more axis title, R in millimeters. And so, oh yeah, the title we were supposed to add is if the machine needs to be maintained or not. So we add a chart title. And we have two reasons. This machine is doubly out of spec. So the machine needs to be maintained. So it's not in spec. I think that's it. We have average, lines, markers, data. Looks good. And then lastly, we want to add a Shepherd sheet enabled problem 4. We want to solve this equation, and so we basically set up the coefficients in your A matrix, and so it's 3, minus 3, 4, 1, 5, 1, 2, minus 6, 1, 1, 3, minus 1, 3, minus 2, minus 3, 2. And then we need a separate column. This is your C matrix. It's 8, 7, 1, 20. And you can do inverse of A. And then you need to set it up to be the same size. So this is a 4 by 4, so this is 4 by 4, and then it's M inverse. And the array, and then you hold down Control and Shift and hit Enter, and you're good to go. And then your answer, again, will be 4, and so this is M inverse M molt, and then it's the inverse and C, and then Control Shift Enter, and there's your answers. So this is W, X, Y, and Z. You could have also done it in one step. So it's equals M inverse, it's M, the multiplication of the inverse of A and C, and Control Shift Enter. There's your answer as well.